Assalamualaikum warahmatullahi wabarakatuh. My name is Nabilatul Ariqah Binti Kamaruddin, and my group member is Nabilah Binti Muhamad Jamil from group 6 will be presenting elementary particles. There are two classifications of elementary particles, which is lepton and hadron. Lepton is a particle that experiences all basic forces except for strong force, which is the strong nuclear force. It is also a particle that does not have any internal structure. Thus, it is non-subdividable into smaller bits. There are three generations of lepton family. The first one are electron and electron neutrino. The second generation are muon neutrino. And the third generation are tau neutrino. Next, moving on to hadrons. Hadrons is known as the particles that experience all basic forces. There are two types of hadrons, which are baryons and mesons. For baryons, it consists of protons and neutrons. However, for mesons, it only consists of pions. Both particles have internal structure. For instance, baryon is a combination of three quarks, while meson is composed of a quark and antiquark. Hence, from these elementary particles, which is leptons and hadrons, four basic different forces will join them together to create nuclei or atoms. The basic forces mentioned before consist of the strong nuclear force, electromagnetic force, the weak force, and also gravitational force. I will start to present with the weakest force among all, which is gravitational force. Gravitational force is a type of force that acting on matters that have masses, whereby it attracts between object to another object. Next, the weak force. The weak force is a type of force acting on quark and lepton. It has a range of 10 with the exponential power of negative 38, and it is stronger than gravitational force. The third one is the electromagnetic force. It is a type of force that acting on charges, either positive or negative charges. It has a range of infinity. It is also obey the inverse square law, and the strength of this force is stronger than the weak force, but weaker than the strong nuclear force. The combination of negative charge to positively charged nucleus will form an atom. However, only positive and negative charge will be attractive to each other. For charges with similar types, which is negative and negative, or positive and positive, will be repulsive to each other. Last but not least, the strong nuclear force. It is a type of force that acting on quarks. It has a range of 10 with exponential power of negative 16, and this kind of force will combine three quarks to form a nucleon. And from the nucleon, with the similar force, will be combined to each other to form a nucleus. Compared to all basic forces, the strong nuclear force is the strongest one.
I'm going to continue the presentation with subtopic quarks. First of all, let's see the properties and definition of quarks. Quarks is a fundamental particles. What does it mean by fundamental? It exists as one and cannot be split. There are 6 quarks overall, and each quark has corresponding anti-quark. Quarks are acted on by the strong force. The strong force binds one quark and one antiquark to form meson, and also binds 3 quarks together to form a baryon. Quarks are free to move but confined in the hadron. A quark has either 1/3 or 2/3 of the charge of an electron. Next, moving on to the quark family, there are 6 quarks and each carries a charge. The first quark family is the first generation, which consists of 2 quarks, up and down. Up with the symbol of U and the charge of 2/3 of an electron, and down with the symbol of D with the charge negative 1/3 of the charge of the electron. Next, the second generation of the quark family, we have the first one, strange, with the symbol of S and the charge negative 1/3 of the electron, and you also have charm with the symbol of C and the charge 2/3 of the charge of an electron. For the last generation or the third generation of the quark family, the first one is top with the symbol of T and the charge 2/3 of the charged electron, and also have bottom with the symbol of B with the charge negative 1/3 of the charge of an electron. That is the 6 quarks and the quark family with 3 generations. The next subtopic is the proton and neutron. Proton and neutrons are baryons, therefore each of them is composed of 3 quarks. The first one, let's look at the proton. The quarks in the proton is U, up, and down, U, U, D. Meanwhile, for the neutron, we have up, down, U, D, D. From this, we can see the charge of the proton and neutron. For the proton, we can see the charge of up quarks is 2/3 of an electron. So we have to plus all the charge of the quark, 2/3 of the electron, plus 2/3 of the electron, plus negative 1/3 of the charge of an electron, and we will get the charge of proton is 1. And for the neutron, we can see 2/3 of an electron and plus negative 1/3 of an electron plus negative 1/3 of an electron, and we will get 0. So we know that neutron, the charge of neutron is neutral, so it's 0, and proton 1. This shows more examples of hadron, baryons, and mesons. The another examples of baryons and mesons is the first one. For the baryons, we have sigma positive, sigma negative, and also lambda. Sigma positive with the quark composition UUS, sigma negative DDS, lambda UDS, and mesons. Pion positive, cation negative. For pion, we have the quark composition UU, and for cation U and S. Next, we're going to discuss for the beta minus decay subtopic. The nuclide carbon-14 is unstable and decaying by emitting beta minus particle and then transforming into nitrogen. Since all the nuclei of carbon-14 are identical, we expect that the beta minus particle will carry the same amount of energy, but surprisingly, it is not. We can see from the graph here, the kinetic energy ranging from the lowest to the highest of the kinetic energy, T maximum. Why this happened? This happened because there is another particle emitted at the same time as beta minus particle, which is being called as neutrino. So, because of this, not all beta minus particles carry the same amount of kinetic energy, some carrying less and some carrying more, although they originated from the same source. So we can see from the equation here, carbon-14 will decay and transforming into nitrogen, and also beta minus will be emitted along with the neutrino. For the last one, we are going to discuss neutrino in more detail. There are some properties of the neutrino. The first one is a neutrino is uncharged. The mass is almost 0 and it is a lepton, so it interacts through the weak force. Because of these properties, they do not generate visible tracks in the cloud chamber. And also, this means that neutrinos interact with nuclear particles only within distance of magnitude 10 to the power of negative 17 meter. And because of this distance of magnitude, there is only a small chance to undergo interaction. That's all from us. Thank you.